long, 0.19 meters wide, and 0.15 meters high. So we are looking at a block of cheese that is in the shape of a cuboid. Always helpful to actually draw out, although it may not be necessary for us to draw it proportionally. Okay. Part A, if the block of cheese is molded to form a cube, so what does molded actually mean? That means what we currently have, it is being probably melted or something, okay, and made into a cube shape. So it is being transformed, okay, into a cube, right? Although I think it's a little bit strange that we are melting the cheese and making it into a cube. A bit illogical, huh? Okay. We want to find the length of each side of the cube. So the volume of the cheese is actually being preserved. Hence, what we need to do is to find out the volume of cheese first. Okay, so we find the volume of cheese. Then after that, we can find out the length of each side of the cube. Since it is a cube, we know that the volume of cube will be L times L times L, which is equal to L cube, which means that to find the length, we will take the cube root of the volume, okay, and then we'll get the answer. Right, so I leave it to you to do that calculation. Okay. Then for part B, which might likely be the part that is challenging, we are going to cut out cubes from the rectangular block. What this means is that from the original cuboid that we have, we are going to try to cut out, okay, cubes like this. So we have done a similar question before. We know that if I'm going to cut out, then I reach a stage whereby I cannot cut out. So maybe got some excess over here. Okay, that might actually happen. So I cannot go and take the volume of the cheese and then divide by the volume of the 2 cm cube. Right? So what we need to do is to figure out how many cubes can be arranged along the length, how many can be cut out along the breadth, and how many can be cut out along the height. Okay, so right, erase this part and okay, so because it is 2 cm, down here is all in meters, you need to do a unit conversion. So maybe we do 2 cm, convert it into meters. That is by dividing by 100. So we get 0.02 meters. So the number of cubes, okay, along the length, that will be to take 0.24 divided by 0.02. Okay, what you get over here will be 12. Along the width or the breadth, whichever you want to call it, will be 0.19 divided by 0.02. That will come out to be about 9.5. So we can only cut out 9. Okay, and then along the height, I'll continue here. That will be to take 0.15 divided by 0.02. Okay, and that comes out to be 7.5, but we need to round down, so that will be 7. Okay, so therefore, the number of cubes in total will be 12 times 9 times 7. Okay, and then we'll get the answer. Anybody else also cannot do question 8? Okay, then currently you know how to find, you know how to find the one. Calculation error. Then okay like that, go through it, yeah? Okay. Then question 12. Okay, this one over here. It says that a fish tank measuring 80 by 40 by 80 by 40 contains water to a height of 35 cm. So again, it is a cuboid. So let me adjust this cuboid. Okay, so 80 cm by 40 cm contains water to a height of 35. Maybe somewhere. I want to see. Okay. You want to find the volume of water, so length times breadth times height. That will be 80 times 40 times 35. Question 1 is in liters, so 80 times 40 times 35 will give you an answer in cm cube, which is the same in ml, and then we need to divide by 1000 to get it in liters. Okay, so I'll leave that calculation part to myself as well. Then, actually part 2, this one we did it yesterday, right? Okay, the surface area of the tank that is in contact with the water, we need to consider 5 different faces, left and right, front side, back side, and then bottom. Okay, the top part doesn't touch the tank at all since it is an open tank. Okay, so part 2, surface area. Okay, so maybe let's count left and right first. That will be 40 times 35, then times 2. Then front and back, front side is 80, height is 35. So times 2 again, 80 times 35. Then the bottom part is 80 times 40. Okay, then we'll get answer. Right? Questions? So I hope those who raised the hand, you realize where you went wrong. Okay? I don't think it is a matter of you not knowing how to do. I mean, it might be a calculation error. Okay? When you're done, can you pass your homework down to the front? Need to be meter square. Oh, then after that change cm, right, cm square, then you divide by 10,000 to change into meter square. Then place it in the stack here. Okay. Alright. Let's continue and try to finish as much as we can for today. Okay. Okay, not sure whether you recall, we have this question in our SLS. Do you remember this question? Okay, I just want to run through it because I think some of us might be still a little bit confused in terms of perspective from a neck and then closing up to be a prism. Now, first thing that we need to acknowledge and realize is that these triangles over here, okay, they are of the same size, same shape. However, the length of each side is actually different. Okay, we cannot assume that it is the same. It is obvious over here, if I down here 4.09, down here 3.64. Okay? Oh, okay. Okay, so in order to determine the value of A over here, you need to imagine how it looks like when it's being closed up. Okay, so when it is being closed, this side will align with this side over here. And this is a rectangle, which means that the length of this is the same as the length of this. Okay, so therefore your A will be 2.61 cm. Okay, then what about B? Okay, so B will consist of this 2.61 and then this length over here, which we already know it must be 4.09. Okay, so we know 2.6, so we know 4.09. The next question is, what is this length going to be? Okay, we recognize that this is a rectangle, but because the triangle doesn't have all sides the same length, that means that your rectangles are also not of the same size. We cannot say that this rectangle and this rectangle are the same. So this length over here, it actually aligns with this side, the longer side of the triangle, which is actually the same as this part here. Okay? Or you can see as this side being the same as this, which will align with 3.64. So therefore it is 3.64 over here. So that explains why B will be equals to 2.61 plus 4.09 plus 3.64. Okay? Right? Because I noticed that some of you gave me the 9 point something answer. Okay, it should come out to be 10 point something. Right? Okay, so that is regarding the nets. Yesterday we have completed our cuboids and cubes already. Today I want to go into prisms and cylinders. Yesterday I have also gone through a little bit regarding prisms, where I show you this animation, okay, that tells us that the volume is equals to base area times height. So I hope you have filled up your worksheet regarding volume of the prism. Okay. Then regarding surface area of prism, okay, I have also shown you how the prism open up such that when it opens up, all the lateral sides, lateral means the one that are around, those are rectangular in shape. Okay, so the ones around will open up to become a full rectangle, whereby the length is actually the perimeter of the base, and then the height, okay, of the entire prism will give us the breadth of the rectangle. Okay, so therefore we can simplify the process of finding surface area of prism to be perimeter of base, or you can call it the cross section, times the height, okay, followed by adding 2 times of the base area. components when it comes to surface area of prism. Okay. Right. So regarding cylinders, okay, the formula actually applies the same way because cylinders are just a very special case of prism. Your uniform cross section, they're all circles. So the base area will simply be a circle. Hence, volume of cylinder is your base area times height, whereby we can have this formula pi r squared h. Okay, because the area of circle is pi r squared. Okay. Then, for a cylinder itself, it opens up, okay, to form two circles and one rectangle. Yeah. Okay. So, long time ago, there was one. I did show it to my students. I asked them, "What shapes do you see?" What do you think they told me? Huh? They tell me divide. I say divide is not a shape. What? Yeah. Okay. So the shape is one rectangle, two circles. Okay. So that is what it opens up to. So when you actually close it up, we notice that the length of the rectangle here, it wraps up to give us the circle, which I think you also saw from the video as well, right? Okay. You saw how that teacher actually showed us. Right. So it wraps up. So that means our surface area of cylinder can be calculated with the same logic. Instead of parameter, we're looking at circumference of the circle, which is pi r, and the height is h, plus pi r squared, because there are two circles. This is only if it is a closed cylinder. Okay, in open cylinder, then you'll just only have one circle, so one pi r squared will be. Yes, a cylinder is also a prism because it has uniform cross-sectional area. Yeah, so I said just now, special prism. Okay, so maybe you can create a prism song. Just like how many things are parallelograms, okay, we can have many things to be a prism. Okay. Now I looked at your responses for SLS. I taken note that some of you need help for some questions. In particular, for example 7, for example 8, as well as practice now 9, question 2 if I'm not wrong. Okay? So I just want to go through the questions just in case some of you don't understand how to do this view. Okay? So I'll just go through it fast because for example 7 is really printed inside your textbook. Okay, the diameter of the base of the cylinder is 14 cm, so always helpful to draw a diagram. Diagram really doesn't have to look perfect. Okay, so diameter 14. Then the height is half of its base radius. So we need to be careful about what this question is saying. We are talking about the radius. So we can find the radius to be 14 divided by 2, which is 7 cm, because we're given the diameter. Which means that the height is actually half times radius. Okay, so height is equals to half times 7, which is 3.5 cm. Okay, so therefore the volume, by applying our formula of pi r squared h, we will get pi times 7 squared times 3.5. Okay. You may need to answer in exact in terms of pi if you want to, but if the question did not expect an exact answer, you may just press it into your calculator and then you will get 538.78 cm cube, which is 539 cm cube when rounded to 3 sm. Okay, so that's for the volume. Okay, questions? Right, so in a typical question like this, we just need to be very careful of what they say and what they have given you. That they have given you diameter in this case, so we need to divide by 2.5 meters. Okay. I think example 8 is the one that might be a little bit challenging to understand what is it trying to say. So it's talking about a pipe, so maybe you can draw your cylinder like that. Because to me pipes are horizontal. Okay. So it says that the pipe has a radius of 2.8 cm, okay, and discharges water at 3 meters per second. So that means water comes out of it, okay, at a rate of 3 meters per second. So 1 second itself, 3 meters worth of water actually comes out. That is what it's trying to say. Okay, we want to calculate the volume of water discharged per minute. So in 1 minute, how much water is actually out? And then we want our answer to be meters. So in this question, we need to pay attention to the units involved. We have 3 meters per second and 2.8 cm. So we need to do some unit conversion first. Okay, so up to your preference, maybe you want to convert 3 meters into cm. Right, so that will actually be 300 cm. So, based on what the question is saying, in 1 second itself, this amount of water comes out. So that means that using our volume of cylinder, pi r squared times height, that will be pi times 2.8 squared times height of 300 cm. So if you were to key this into your calculator, we can get approximately 7389.02. Now at this juncture, I want us to take note that look at the answer that I've given over here. This is not yet the final answer, but I decided to not follow truncated 5SF. Because truncated 5SF would have been 1, 2, 3, 4, 5. I would have stopped at 0. Why did I give one more digit? It is because this number itself is fairly large. Okay? It goes into thousands. Right? So if you only go by 5SF, right? Okay, then you will realize that when I do subsequent calculation, your value keeps on getting deleted in some sense. Okay? It keeps getting reduced. So to maintain higher accuracy of the answer, you may want to consider having 2 decimal places instead. Okay. So for example, if my value were to come out to maybe 17,204, okay, this is truncated 5SF. But later on, if I do my calculation, my answer will actually be affected because of the accuracy that I've taken up. So maybe it will be nicer if you take in 2 more digits subsequently. Okay. So that is the volume of water that is being removed or discharged in 1 second. We want to find per minute. So in 1 minute itself, all I have to do is to take the volume of water for 1 second and multiply by 60. minute 60 seconds. And that will be about the 443341 point. Okay, so like this one, you see the value is very big. If I were to strictly follow truncated 5SF, then end up I will round off, you know. Okay, instead of 41, you have become 40. Okay, then it wouldn't be a very good accuracy to take. So that's why very large number, we take truncated to dB. Okay, so this is in CMQ. Yeah, let's see. Yes, you can need to answer it in pi, that will be even better, even more exact. Okay, I'm just saying in case some of us have situations whereby maybe it's not in pi, maybe it's a cuboid, okay, then the answers wouldn't be in pi, right? So there's a volume of water in 1 minute and it's in cm cube. So in order to do the conversion, we know that cm cube is the same as milliliters. And to convert milliliters to liters, we divide by 1,000. So I will get 443.3412 liters, for which I will end up rounding off to 3SF. That will be 443 liters. Sorry, a little bit of squeeze on this side. Your cylinder around in case you want to see. Okay, questions? Okay, I'll erase these formulas here. Was practice now 9 question 2. 11 of you asked for this. Okay, so that's 1/3 of the class. Right? Okay. Now this one, question 2. It says that the figure shows a section of a steel pipe of length 12 cm. Then there's internal radii and external radii. Okay, by the way, radii is plural. Okay, radius is singular. Okay, right? If radii is singular, sorry, I suddenly confused myself. Radii is singular, right? Radius is singular, radii is plural. Okay, yes. Sorry, I suddenly confused myself. Okay, part I, we want to show that the area of the cross section, okay, is actually 1.84 pi. So the cross section is actually this donut shape. I hope you grow up seeing donuts the same way as I do. Okay, donut got the ring inside one, right? You all eat before donut? No? So I need to buy your Ferrero Rocher now and then also donut. Okay, need to wait. Alright? Okay, so we need to find out what is the area of the cross section. Okay, so that means you need to take the big circle minus away the small circle. Okay, so area of cross section. For the big circle, you will have the big radius. Okay, so it will be pi times 2.5 squared. Okay, pi r squared. Then minus away the small circle, which is pi times 2.1 squared. will press into a calculator 2.5 square, then we will get 6.25 pi. Okay, so the pi you just leave it out, then you put it at the back. Then 2.1 square, you also press calculator, you will get 4.41. Then you place the pi at the back. Okay, then you will have 1.84 pi cm squared. And since the question says show, we will end off by indicating in brackets shown. Okay, so that is how we go about doing shown questions. Okay. Now one good thing about shown questions is that if you don't know how to do part I, okay, you can still do part 2 and 3 one. Alright, you can still take this answer and then after that work out the answers for the remaining parts. So don't actually stop yourself from completing the rest of the question. Yes, Francis. Yes. Okay, then part 2. Find the internal curved surface area of the pipe. So internal curved surface area refers to the inside of the pipe. Okay, so for example, your water bottle or we have this cylinder over here, inside. Okay, so the inside is a smaller cylinder that has radius 2.1. And we know that it opens up to become a rectangle, alright? So the internal surface area your length times breadth. Your length is actually your circumference, okay, so 2 pi r. And then the breadth is actually 12. Okay, so since the earlier question asked for things in exact already, maybe we can have a good practice of leaving our answer in exact as well. So that will be 50.4 pi. So if in the exam you forget this formula, okay, I think at least you must know your area of circle pi r square, circumference of circle 2 pi r lah. Right? Then in the exam, you cannot imagine cylinder, just take exam paper, you roll it up lah, okay? You roll up your paper. Alright? But if it's a prism, then of course don't cut out your paper lah. So can still see one, right? But of course you don't raise it up high lah, then everybody can see you doing this, then everybody see your answers. Okay, so then that will be cheating, you also get yourself in trouble. Okay, then part 3. Hence find the total surface area of the pipe. So the total surface area will consist of the cross section because there is that donut shape on top and at the bottom. Then we also got the internal and also the external. Okay? Whenever we're asked to find the total surface area, you must imagine, given that object, if your hand can go and touch the places, that means that it is a surface that needs to be calculated. So imagine you have this object, I can touch the outside surface, I also can put my hand inside to touch the curved surface inside. Okay? So long as it is touchable, that means it is a surface area to be counted for total surface area. But of course, you don't tell me that this 2.1 cm very small, your hand very big, cannot touch lah. I'm just giving an example. Okay? So long as it is touchable in that sense, okay, you will calculate it. Right? So total surface area. Okay? 2 times of your donut, okay, plus the internal, which is 50.4 pi. I realize I forgot units over here. Then plus the surface area on the outside, okay, which will be 2 pi r 2.5 times the height again. Okay, so the same way of calculation for the internal curved surface area. Then you can press everything into calculator, or if you want to leave it exact, also can. Okay, you will come up to this, or if you don't want to be exact, since the your cylinder and your prisms. Yeah. Circles on top. Take the circles on top. Sorry, I didn't catch what you're saying. Can you repeat again? Find a big circle, then this one, in here what? Big circle minus small circle. Right? Okay? Now we have 20 minutes left. I want to finish up this chapter, then we really can do our revision well and strong. Okay, let's go into composite solids. I only got 2 questions to cover. Okay, first type of composite solid. Now what is a composite solid? Composite solid simply is where 2 objects, 2 kind of shapes, they put together. That is composite solid. Okay, sometimes it can be put together like what we have here, or it can also be something being dug out. Okay, so for example, this one here, we have a cuboid originally, and then dig out a half cylinder. Okay, so there are different ways of solving. So I'll focus on these 2 questions here. Alright. Now, in this question, we want to find volume. Okay, volume is simple. When it is being placed together, for example, okay, I have Kyra's water bottle over here, and then after that I have Carmen's water bottle. I put together, what's the total volume? If I have this one 1 liter, this one 500 liter, okay, 500 ml, I just take and add together, right? Volume is simple, right? If I were to dig out, okay, a certain shape inside. Okay, for example, maybe I open up her flask, very sad job. If I open up her flask and inside, maybe it's not a circle. Inside maybe it's a square. Okay, it's a prism. It's a cuboid. Okay, then I will take the cylinder minus away the shape inside. So for volume, okay, it is straightforward. Be it whatever object we're given, if it's combined together, we just add. If it's being dug out, we subtract. Okay, simple concept. So, to find the volume of this, okay, you can think of finding the cuboid and the quadrant cylinder separately, or we know that if I were to cut this, okay, I have actually a cross section. So imagine you have a loaf of bread that is of this shape. If I take a knife and I cut it, every single slice will be this shape. Okay? And I know that for prism, it will be base area times height. Okay? So I can find the base area of this, and then I times the height. So that is one way that we can do it. Okay? Rather than calculating separately. So the base area consists of a rectangle, this rectangle here, which is 14 times 9. Okay, and then we have a quadrant. Quadrant meaning to say 1/4 of a circle. So 1/4 times pi r squared, because pi r squared is the formula for area of a circle. Now my question is, what is the radius of this quadrant? Are you able to see what is the radius of this quadrant? 14 or? Okay. How and where do we see it? Your radius, don't just think about horizontal lines like this. This side also radius. Okay, which is the same as this side here. Right, so it is 14. Okay. So it takes a little bit of visualization. So while the concept of finding volume is simple, but it needs to have some perspective to see your values. So if you want to leave the answer in exact, this will be what you get. Otherwise, you can press everything in calculator and then calculated 5 SF because this is not yet the final answer. Okay, we are trying to find the volume, which is the common base area, the uniform base area, times the height. So in this case, we are slicing this, okay, from front all the way to the back. So the height is actually 20 cm. Okay, so the volume will be to take base area times height 20. And that will be 5,600 cm3 in 3SF. Just a quick recap, why is it 5,600? 3SF is 1, 2, 3, stop at 9. Okay, 8 will cause the 9 to round up, becomes a 10. That's why 5 need to convert to become 6. Okay? That this is a prism already with the uniform cross-sectional area this way. To find the total surface area, we apply the similar concept over how we find prisms as well as for your cylinder. Where we open up, okay, length of the rectangle is your circumference or your perimeter, and then the breadth of the rectangle is the height. So to find the area of all the sides around, okay, I'm talking about around, okay, it will be very complicated and troublesome if you want to find out piece by piece, okay, because down here you need to find the curved one, then you've got the rectangle, then you've got rectangle at the bottom, another rectangle here, very troublesome, okay. So we do the simple way of taking the perimeter of the base, the common base area, okay, the cross section, take the perimeter, and then we times what? We times the height. Okay, so the height will actually be this one here. Alright, and that will give us all around already. Okay, you all see? Right, so perimeter of the cross sectional area times the height will give us the area of all the surfaces around. Okay, then I need to add in 2 of the front and back. That's all I need. Okay, so my calculations. Okay, total surface area. So for the ones all around, that's what we call lateral sides. The perimeter of your base is 14 plus 9 plus this one is actually 14. Okay, plus this curve over here is 1/4 of your circumference of circle. Okay, followed by plus another 9. So this actually gives us our perimeter. Okay, perimeter. Then we times the height, which is 20. So what we have over here is the area of all the sides around. Which we call lateral sides. Okay, and then we don't forget about the front surface and the back surface, which is actually the base area, which the answer we got over here already. So 279.93 times 2. So this is the front and back. Okay, I'm combining all the calculations into one statement, which you can do that. Otherwise, you want to separate around one. Surface area, you can touch this front, right? You can also touch the back, so I still need to count the area of the front, which is this base area here, and then also the back. So 2 of it. So 2 times the front and back. Okay. Questions? Okay. So if you want to key everything into calculator, you will come out get about 1919.68. Okay, that's 1920 cm squared 3sm. Exercise